Guys, welcome back to this lesson. So in this lesson, we'll be looking at the magnitude of a vector. Magnitude. So in the previous lesson, you heard us talking about magnitude, which is also the size. But in this form, when we talk about magnitude here, we mean length, we mean distance. Okay, and that is why scalars are characterized by magnitude. Magnitude means distance. Okay, so the magnitude of a vector is the length of the line representing a vector, which is also the distance. Okay, so we can use distance to just represent it. Okay, so distance. Remember, magnitude is not the same thing as the displacement. Displacement, you have to do the calculation the way we did it there. So it is denoted by the absolute value of A and B. So actually, distance is the absolute value of displacement. So when you calculate AB, which is B minus A, you get a displacement. But when you take the absolute value of your answer, then you get what is known as distance. And it is sometimes called the modulus of the vector. So, well, we can call it modulus. Look at the name. So anywhere you see any of these four names, magnitude, length, distance, modulus, it means the same thing, and what you should calculate is the modulus of your answer. Okay, so to calculate the magnitude of a vector, we use the Pythagoras theorem. Okay, so let's see if we have the theorem here. If we don't have it, we are going to derive the theorem. Okay, all right, so we have the pattern. So using Pythagoras theorem here, if we have okay, so the displacement here is the displacement in the vertical direction is y, and that of the x direction is x. So the magnitude of x comma y, okay, so the magnitude of x comma y here is going to be equal to square root of x squared plus y squared. Okay, and then if we have the vector in this form, uh, let's say we have xi plus yj. Okay, the magnitude will be still be the same thing, square root of s squared plus y squared. Note that square root of I squared is always equals to 1, and j squared is always equals to 1. So the I and the j will disappear, and what we just have is the number. So this is how you compute magnitude. And then, of course, if we have a three-dimensional vector, we're going to do the same thing. So the magnitude of the vector x, y, z, okay, will be equal to square root of x squared plus y squared plus z squared. So also, if we write it in column form of unit form, and then you have xi plus yi plus zk, the magnitude will still be the same thing. Magnitude of xi plus yj plus zk, okay, will be equals to square root of x squared plus y squared plus z squared. Okay, so it doesn't matter whether it is in unit form or in column form. You can always take the magnitude, and of course here as well, magnitude of k squared is always equals to 1. Okay, or magnitude of k is equals to 1 as the k may be. You can remove the square, you can leave it, it's the same thing. So let's just remove that. So I'm going to remove the square from here as well. The square does not make sense, it doesn't have to be there. Okay, alright, so this is the formula for magnitude. You just apply the Pythagoras theorem, take the square root of the square of the sum of the squares of the component. So let's look at the formula. Calculate the magnitude. So we have a magnitude of 5i plus 3j, that will be equals to square root of 5 squared plus 3 squared, which is square root of 25 plus 9, which is going to be square root of 34. Okay, we don't put plus or minus, let's leave it like that. Okay, and if the answer is not in short form and you are not asked to simplify, you can still leave the answer like that. Okay, so for b, we have a magnitude of 2i minus 4j plus 4k, okay, equals to square root of 2 squared plus minus 4 squared plus 5 squared, and that is going to be square root of 4 plus 16 plus 25. Okay, so that will be square root of 45 again, and that is 3 root 5, right? Yeah, because 45 is 9 times 5, square root of 9 is 3, so take 3 out and then we have 3 root 5. So this is how you compute magnitude. C, 1 minus 70. So C, 1 minus 70. So we have 1 minus 7 is 0. So we have to find the magnitude, put the line. So when you put the line, then it represents magnitude of the vector. Well, before you calculate magnitude, you must put the modulus line, because that line represents shows that you are finding magnitude. Okay, so the magnitude of this is going to be square root of 1 square minus 7 square plus 0 square, and that is going to be 1 plus 49 plus 0, which is square root of 50. Okay, and that is going to be square root of 25 multiplied by 2, which is 5 root 2 as the answer. So one final example. So take D as your classwork, guys, and then let's take the 10 minus 5 10. D, we have 10 minus 5 10. So this is 10 square plus minus 5 square plus 10 square. Okay, that is 100 plus 25 plus 100, and that is going to be 225, right? What square root of 225? I think is a perfect square, right? Yep. That's 15. So let's cross check. So this is 5, 7, this is 5, and this is 1. Okay. 5. Really? 125? Okay, so it's not 225. So but this number should be something, right? 5 times 5 is 25. 5 carry 5 times 7. 1 here 5, 1 here 2. So we have 5, we have 2, 12 carry 1, yeah, it's 15. So the square root is 15, and that is the answer. So you can see that magnitude does not have direction, it is just a number. So magnitude of a vector is a scalar. Okay, so magnitude of a vector is always a scalar. All right, so let's look at equal vectors, negative vectors, and unit vectors. So we have three parameters here. So let's take them one after the other. Equal vectors. So equal vectors. Two vectors are equal when they have the same magnitude and direction. So here we talk about same magnitude and same direction. Okay, so that's when we talk about equal vector. E.g., if we have A equals to 3i plus 2k, and then we have B equals to let's say 3 2. You know that 3 2 is the same thing as 3i plus 2 plus, sorry, yep. So let me represent it very well. So you can see that one dimension is missing here. So this is 302. Okay. So if we represent this, we'll have 3i plus E0j plus 2k, and that will be 3i plus 2k. So here we can conclude that A is equals to B. Okay, and that is equality of vectors. When vectors have the same magnitude and the same direction, then they are said to be equal. So let's take the next parameter, negative vectors. So negative vector is a vector that is negative. Okay, negative vectors. So we talk about negative vectors when we have a vector that is going in opposite direction. So if we have these two vectors, let's say this is vector A and this is vector B. So this is A going upward and this is B going downward. This is B. So if A is equals to 2i plus 2j, uh, B will be equal to minus 2i plus 2j, okay, which is equals to minus 2i minus 2j, okay, and that is exactly equals to minus a. You can see that b is the opposite of a, so negative vector is a vector that is going in opposite direction. They have the same magnitude but different directions, so you can characterize negative vector as a vector with same magnitude, okay, opposite direction, opposite direction. So hope you understand the terms and what we are trying to explain. Okay, all right. Then we have one more parameter then. So we talk about unit vector. A unit vector is when you divide a vector by its magnitude. Okay, so unit vector is defined thus: unit vector. So if we have this and then we have this, we talk about unit vector. You know that if we have vector A equals to 3i plus 2 plus 2j, okay, plus let's say 4j minus 3k, we can find the modulus of this vector, absolute value of A, as square root of 3 squared plus 4 squared plus minus 3 squared, right? And that will be 9 plus 16 plus 9, and that will be 18. 18 plus 16 is what, guys? So this is 4 and this is 34, right? So that will be square root of 34. So if we now write a unit, a vector a over modulus of a will be equals to the vector 3i plus 4j minus 3k all over square root of 34, okay, and that will be 3 over square root of 34i plus 4 over square root of 34j minus 3 over square root of 34k. 34k. So the parameter we have here, uh, a all over magnitude of a is what is known, let me write it very well, a over magnitude of a is called a unit vector, which is called unit vector a, unit vector a, okay. So that is unit vector. So this is how you compute unit vector. You divide the vector over its magnitude. So when you divide the vector by its magnitude, then the result is called a unit vector. Okay, so unit vector is not a particular name, it's just taking the vector over its absolute value. And unit vector give rise to what we call the direction cosine. Okay, so these parameters that we have here, 3 over square root of 4, 4 over square root of 34 minus 3 over square root of 34, they are also called direction cosine, the direction of I, J, and K respectively, so which we are going to discuss when we get there. Okay, so you understand better. Okay.